What if you looked up at the stars tonight and saw a second moon burning furiously in the dark? A blinding, fiery beacon so intensely bright that it casts distinct shadows at midnight. That isn't science fiction. Right now, exactly 650 light-years from Earth, an astronomical time bomb is silently counting down to zero. It is one of the brightest objects you can see with your naked eye, but its core is actively collapsing. When it finally detonates, it will unleash a terrifying wave of radioactive fury. This is Betelgeuse, the ruby-red anchor of the Orion constellation. To say Betelgeuse is massive is a laughable understatement. If dropped into the center of our solar system, it would consume Mercury, Venus, Earth, Mars, and the entire asteroid belt, its fiery plasma extending almost to Jupiter. If you stood on a hypothetical planet orbiting this star, the sunset wouldn't be a perfect sphere dipping below the horizon. It would be a lumpy, shifting blob of furious red plasma taking up half the sky, violently pulsing as if the star itself were breathing. Yet, despite being nearly 900 times wider than our sun, it only possesses about 10 to 15 times the mass. This makes Betelgeuse a bizarre cosmic paradox. Its outer layers are spread so incredibly thin that its density is actually lower than the air you are breathing right now. It is effectively a red-hot vacuum. Because its gravity is so intensely weak at its outer edges, the star barely holds itself together. Huge, violent convection cells of superheated plasma constantly boil to the surface, bursting and sinking like a lava lamp the size of an entire solar system. But its immense size hides a fatal flaw. Betelgeuse is dying, and its death will be one of the universe's most violent events. We observe hundreds of supernovae annually in distant galaxies, but in our own Milky Way, they are incredibly rare. We might see 2 or 3 a century. So what happens when one goes off in our cosmic backyard? Before we uncover exactly when Betelgeuse will unleash its deadly blast, hit that subscribe button for raboscience and drop a comment below. Would you want to see a supernova in your lifetime? Let us know. It all comes down to the kill zone. If a supernova detonates within 50 light-years of Earth, it is game over. The initial blast of gamma radiation would strip away our ozone layer in an instant. Without that invisible shield, lethal ultraviolet radiation from our sun would fry the surface. Phytoplankton in the oceans would die off, crashing the global food chain. Earth has the physical scars to prove it's been hit before. Deep at the bottom of our oceans, scientists have discovered thick layers of iron-60, a radioactive isotope forged exclusively in the dying hearts of massive stars. Incredibly, an even closer blast may have occurred just 13,000 years ago. Paleontologists have uncovered woolly mammoth tusks peppered with microscopic impact craters embedded with highly radioactive iron. These tiny cosmic bullets slammed into Earth at 10,000 kilometers per second. Some researchers even argue that this orbital shrapnel triggered climate shifts that helped wipe out the mammoths. To understand why a star detonates, we have to look inside its core. Stars are locked in a brutal war between two forces: gravity, which wants to crush the star inward, and the outward pressure of nuclear fusion. Betelgeuse survived by fusing hydrogen into helium. But massive stars are gluttons. When hydrogen runs out, gravity squeezes the core, heating it until helium ignites, fusing into carbon. Then carbon fuses into neon, neon into oxygen, oxygen into silicon. With each new element, the burning phase gets drastically shorter. The carbon phase lasts thousands of years. The silicon phase lasts just days. And then, the star makes a fatal mistake. It fuses silicon into iron, Fusing iron doesn't release energy, it absorbs it. Outward fusion pressure drops to zero. Gravity instantly wins. The entire weight of a star 15 times heavier than our sun crashes down on the core at a quarter of the speed of light. The core compresses until atoms are pulverized. It reaches a point where it cannot compress any further, and the inward force violently rebounds. Boom! Over 1 quadrillion joules of energy are released in an instant. A blinding shockwave rips through the star's outer layers, blasting its guts across the galaxy at a fraction of the speed of light. This is a Type 2 supernova, and it is exactly what Betelgeuse is gearing up for. So, should we be worried? Fortunately, at 650 light-years away, Earth is well outside the kill zone. Our ozone layer will remain entirely intact, and the protective magnetic bubble of our own sun, the heliosphere, will act as a buffer against any incoming cosmic shrapnel. But we will get front-row seats to the greatest show in human history. When Betelgeuse goes supernova, the first warning won't be light. It will be ghosts. Hours before the explosion becomes visible, a massive wave of trillions of nearly massless neutrinos will wash over Earth. These elusive particles pass right through solid planets without slowing down. They travel slightly faster through the cosmic dust than the explosion's light photons, acting like a cosmic siren. Then, the sky will ignite. Betelgeuse will become billions of times brighter, shining as brilliantly as a full moon. It will be so incredibly intense that you will see it clearly in the middle of the day. For weeks, it will cast distinct shadows at night. It will be an awe-inspiring reminder of our chaotic universe. The ultimate question is, when will it happen? For decades, astronomers confidently believed the explosion was still 100,000 years away. But lately, Betelgeuse has been throwing us some major curveballs, making scientists wonder if the timer is much closer to zero than we thought. In late 2019, Betelgeuse did something terrifying. It began to vanish. During an event dubbed the Great Dimming, the star lost nearly 2/3 of its brightness. Speculation ran wild across the globe. Was this the precursor to the supernova? Using the Hubble Space Telescope, astronomers eventually solved the mystery. Betelgeuse hadn't died. It had essentially burped. The star violently ejected a massive plume of superheated plasma. As this plasma moved away from the star, it cooled and condensed into a gargantuan cloud of stardust, temporarily blocking our view from Earth. But the Great Dimming forced astronomers to look much closer. And what they found completely rewrote our understanding of the star. Betelgeuse pulses. It brightens and dims in highly rhythmic cycles. One of those cycles lasts exactly 2,170 days. For a long time, scientists thought this was just the star's internal heartbeat. But recent, cutting-edge data analysis revealed a shocking, hidden culprit. Betelgeuse is not alone. It has a hidden companion star, officially named Sawara, meaning her bracelet in Arabic. This companion is affectionately dubbed Betel Buddy. Astronomers initially expected it to be a dead stellar husk, like a neutron star. But deep X-ray observations from the Chandra Observatory proved them wrong. Sawara is a young main sequence star, roughly the mass of our sun, orbiting Betelgeuse at about the distance of Saturn. Because Betelgeuse is surrounded by an immense cloud of its own shed gas and dust, Betel Buddy acts like a cosmic snowplow. As it orbits the giant, it physically sweeps away the dust, creating a massive, swirling wake that lets more light escape. This completely explains the 2,170-day brightening cycle. Using advanced speckle imaging, Scientists captured direct, blurry evidence of this hidden star. The method takes thousands of rapid-fire photos to cancel Earth's blur. But Sawarha is doomed. In 10,000 years, tidal forces will drag it into Betelgeuse and vaporize it entirely. The presence of a hidden companion isn't the only massive mystery scientists have unraveled recently. For years, Betelgeuse appeared to be breaking the fundamental laws of physics. Using the ALMA radio telescope array, astronomers measured the star's rotation. They calculated that Betelgeuse was spinning at a mind-bending 5 kilometers per second. That is 18,000 kilometers per hour. At its immense volume, that speed is mathematically impossible. When a star expands into a red supergiant, physics dictates it must slow down to conserve angular momentum, much like an ice skater extending their arms to slow a spin. At its bloated size, Betelgeuse should only be spinning at a sluggish 2 meters per second. To explain this impossible speed, some scientists proposed a dark history: stellar cannibalism. They suggested Betelgeuse once had another companion star that it swallowed whole, absorbing its rotational energy and speeding itself up. But groundbreaking research, led by the Max Planck Institute in 2024, suggests something even more fascinating. The rapid rotation is actually a massive optical illusion. Remember those boiling convection cells we discussed earlier? High-resolution 3D simulations revealed that Betelgeuse's surface is turbulent. Plasma bubbles 100 million kilometers across surge upward at 30 kilometers per second before bursting and crashing back down. Because Betelgeuse is so far away, our best telescopes couldn't perfectly resolve these rising and falling bubbles. Instead, the chaotic blue and red shifts of the boiling plasma blended together. The star isn't spinning at impossible speeds. It is just furiously boiling itself to death. Every new discovery proves Betelgeuse is one of the most chaotic, fascinating objects in our galaxy. It is a boiling behemoth hiding a doomed companion, steadily marching toward its own spectacular annihilation. We may not know exactly when those ghostly neutrinos will hit our underground detectors. It could be 100,000 years from now, or the light from its destruction could already be racing toward Earth, set to arrive tomorrow. If you enjoyed diving into these terrifying and beautiful cosmic mysteries, make sure to smash that like button and subscribe to Rabo Science. Turn on your notifications so you never miss an episode. Keep looking up and see you next time.